the square root of 2a is all I can do, minus now 4 times. Now notice I brought the 4 down because I know whatever comes out of this radical has to be multiplied times 4. So I'm going to come over and do the square root of 72a. And I need to break it down, so I have an a and a 2a, and 2 divides 72 36 times, so it's 6 square roots of 2a. Plus 4 times the square root of 8a. Well, 2a times 4. So it's 2 square roots of 2a. So now what do we have? We have the square root of 2a, that's 1 square root of 2a, minus 4 times 6, so it's 24 square roots of 2a, plus 4 times 2, that's 8 square roots of 2a. And now if you circle everything but the number, because that's the concept, those circles have to be identical, then I can count them. I can include them and put them all into 1, and they are identical. 1 circle minus 24 circles plus 8 circles is how many circles? Negative 15 circles. Hmm? 15? I'm trusting you, which is maybe not a good thing today, because I can't trust myself. That's what the problem is. Now, this is your book, and these are kind of different than what we've had before. And this is what your book does to you. And all I do at this point, I just break the sucker down and see what happens. If I take a look at the square root of 49x plus 49, this is the same as the square root of 49 times x plus 1. They make you factor. Now, 49 times x plus 1. 49 is a perfect square, right? So this is 7 times x plus 1. So this first guy is 7 times x plus 1. The square root of x plus 1 plus. Now I should end up with the square root of x plus 1 on the inside. So the square root of x cubed plus x squared is the square root of x squared. Factor out the greatest common factor, x plus 1. There's your square. Square root of x squared is x. Square roots of x plus 1. Now, this is where things get really interesting. And this depends upon how you want to handle this. Because there's a 1 multiplying that x. So that if I were to circle everything but the number, are they the same? No. So can I count them? No. I have 7 circles and 1 square, really, because in the end, this guy's not a circle. We'll make him a square. So I cannot count how many I've got. You can leave it alone. I don't have a problem with that. But what your book may do is this. It says you've got a greatest common factor of the square root of x plus 1. And when you remove it, you're left with 7 and a plus 1x. I'm not exactly sure why you would want to do that, but that's an alternative answer. As far as I'm concerned, if you can't bring them together, you can't bring them together, and you quit while you're ahead and move on. But in your book, if you see something like this, what they did is they factored out the greatest common factor of that radical. Either answer is correct. One is not more correct than the other, is what I'm trying to say. And it's going to be, what you're going to end up using it for. Curtis, do you want to start the roll for me, please? Seeing you guys with your, no, let me finish this as I'm videoing. I don't want this on video. Okay, so now we got the same problem here, except it's a fourth root, and you notice I can rewrite this guy as the fourth root of y cubed over the fourth root of 81 minus 5 times, oh, this is not too bad at all, fourth root of y cubed over 3. Now, what's the fourth root of 81? 3. Now, if the denominators are the same, what can I do? Subtract the numerators, right? Denominators are the same. I've got a common denominator. So it's the fourth root of y cubed minus 5 fourth roots of y cubed.
So it's just 1 minus 1.
So this is, how many fourth roots of y cubed do I have as 1? So it's minus 1. So 1 minus 5 is negative 4. Fourth roots of y cubed.